Welcome back. This is teaching video on section 6.3, Newton's second law. And section 6.3 in your textbook is section 5.3. So we're finally to Newton's second law. To review Newton's first law, an object in motion tends to stay in motion. An object at rest tends to stay at rest unless acted upon by an external force, or an unbalanced force, or a net force. Another way to say it is mass has inertia, and inertia resists motion. So Newton's second law is in the form of a formula, and that is that force is directly proportional to acceleration and directly proportional to mass, and that acceleration is inversely proportional to mass. So it's a relationship between mass, acceleration, and force. So it states that acceleration produced by a net force of an object is directly proportional to the magnitude of the net force, is in the same direction as the net force, and inversely proportional to the mass of an object. So A is inversely proportional to M and directly proportional to F. So this is before the equal sign. If it's directly proportional to the force and inversely proportional to the mass, then A is going to be equal to mass, to force over mass, and force, if you could bring mass up, is going to equal to force, mass times acceleration. So F equals ma. That's how you memorize the second law, Newton. Force equals mass, acceleration. So acceleration is based upon the units of the force. So if the force is in newtons and the mass is in kilograms, then an acceleration is a newton per kilogram, and what you're going to see is a newton divided by kilogram is also a meter per second squared. So you can see that these can be converted. I'm not going to ask you to do it now, but you can convert newtons, which is force, over kilograms of mass to give you acceleration of meters per second squared. So the acceleration is equal to the net force divided by the mass. So if the net force doubles, okay, so let's put that. If the net force doubles, so if your F doubles, what happens to A? Well, it's on opposite sides of the equal sign, so if this doubles, acceleration doubles. If mass is halved, what happens to acceleration? So if this goes down by 2, this goes up by 2, because they're inverse. They go opposite directions. As one goes down by 2, the other one goes up by 2. If both the net force and the mass are doubled, what happens? Well, let's do it again. F equals ma. If I double the force, I should double the acceleration. But if I double the mass, then I'm going to half the acceleration. Well, half of double is just acceleration, so the acceleration remains unchanged. So kind of crazy questions. So here's an example. If a car can accelerate at 2 meters per second, what acceleration can it attain if it's towing another car of equal mass? All right, so if force equals mass times 2, okay, then what acceleration can it do if I double the mass? Okay, so mass times 2 is force. Well, if I double the mass, what have I done to the acceleration? As this goes up, what happens here? It goes down. So if I double the mass, I half the acceleration, which means it can only accelerate at 1 meter per second squared. And there's your answer. So some more. A car has a mass of 1,000 kilograms. What's the acceleration produced by a force of 2,000 newtons? Okay, so I'll just tell you that they're going to cancel, and your answer is going to be in meters per second squared. So F equals ma. So force is 2,000 newtons. Okay, mass is 1,000 kilograms times what? So 1,000 times what is 2,000? 2 meters per second squared. Be 2 meters per second squared. Okay, if the force is 4,000 newtons, what's the acceleration? I think it's the same one, 1,000 kilograms. So if you have x equals ma and you have 1,000 kilograms and you have 4,000 newtons, what happens? It's 4, right? 1,000 times 4 is 4,000. And that's the acceleration. So the more the force, the more the acceleration. How much force must a 30,000 kilogram jet plane develop to achieve an acceleration of 1.5 meters per second squared? Well, I've got force times mass. Force equals mass times acceleration. I want the acceleration to be 1.5. I want this to be 30,000. Okay. So 30,000 times 1.5 equals 45,000 newtons of thrust. There has to be that much pushing out of the back of the plane for a big plane like that to accelerate at 1.5 meters per second. Yeah, right. So what's the relationship among an object's mass, its acceleration, and its force? It's the formula for Newton's second law. Force equals mass times acceleration. Hope that helps.